All set? So thanks everybody for coming to the penultimate Data Club meeting of the year. It's great to see all new faces, and well, except Jeremiah. So this is I don't know, something like the 6th meeting of the year so far. And what we've been doing this semester, of the semester, and what we've been doing this semester, we've been doing a lot of learning about data analysis type stuff using JavaScript, which is a kind of weird way to do this sort of stuff. And today maybe I was really excited about the last session, but this session I'm a little bit more excited about, I think, because there are some things about what we'll be doing today that just strike me as just they're going to change my workflow. So we're starting out by encouraging everybody to go, you can switch, to go to the Columbia Data Club's Observable Notebook page. That's this URL here. And if you go there, you get a list of the notebooks. So for those of you who are new, you can see that these have dates, I think, on them. I mean, it has viewed dates for me. I don't know. But anyway, everything that says day 1 is something that we worked on this semester. Day one. And you can catch up on your own time if you like. And for all of them, if you click on them, they should have a video too. That's a recording of the workshop when we went through the notebook. So that's just a little bit of navigational stuff for you to take home and look at on your own time. Today we're going to be looking at this one called Day 1 Exploratory Data Analysis in JavaScript. So does everybody have this notebook open? The Day 1 Exploratory? Okay. Can you all tell me quickly, again, because you're new, do you have a lot of experience with JavaScript? None at all? None? Do you have experience with programming, like in Python or R? Not at all? No, okay, all right. So for those of you coming from the Python and R world, this will be hopefully especially illuminating. So I just start this by saying, surprise, we can do exploratory data analysis in JavaScript. Everybody, if you take a programming course where you're doing exploratory data analysis at Columbia, you are probably something like 80% of the time going to be doing it in Python, something like 15% of the time doing it in R, and maybe 5% some combination of MATLAB, Stata, etc. Nobody does exploratory data analysis in JavaScript in 2024. But it's possible, and actually it works reasonably well. So exploratory data analysis, or EDA, is just quickly like among the first steps that you do when you're doing a research project and you're trying to learn about your data set. So you try to see what the shape of the data is, what the distribution of every column is, if it's a categorical variable, to see how many values there are for each category, etc. So it's initial stuff. It's not necessarily what you're going to use to make your visualizations that will go into your article or dissertation or anything like that, but it is the sort of thing that will help you understand your data and start being able to tie together questions that you want to ask. In a Python idiom, you usually do this with the Python library pandas and in a Jupyter notebook. So this is a little bit like using a Jupyter notebook and pandas, except if it's in JavaScript. Also plus matplotlib, because we're going to be making charts. In R, this is the equivalent of using the tidyverse and using some combination of dplyr and ggplot. So I had this little question here, why use JavaScript? The answer is I just like JavaScript more. It feels more idiomatic to me, or rather, I can code in JavaScript more idiomatically than in Python or R. But I think that one of my gambles today is that for those of you who do come from a Python environment especially, but in our environment also, will immediately see why I'm talking about this sort of stuff in terms of this is going to change how I do, could very likely change how I do EDA moving forward. So today I made 4 data sets. And these are amusingly from coursework I'm doing right now in the Masters of Data Science program. The first file, and they're all attached to this notebook. So if you click on the paperclip, you'll see them here. They have 1, 2, 3, so there are 4 here. So the first one is the first version of a data set I'm using with my partner Sophie for our own exploratory data analysis and visualization course. And it's a combination of hourly statistics from January 1st, 2019 to June 25th, 2024 of yellow cab and Uber Lyft trips, as well as weather data. Our question is, we're assuming that people don't take the taxi as often when it's nice out. So we're going to take that assumption and use that to try to figure out what does it mean for it to be nice out, like, etc. So that will be fun. I've processed this data, or Sophie and I have processed this data rather heavily, but there are still amusing hiccups that we might see. Lululemon X25000 is a data set I compiled for a different class. It's a sample of 25,000 articles since 2019. Let me rephrase. It's a sample of size 25,000 out of over 100,000 articles since 2019 about Lululemon, which I acquired using ProQuest TDM Studio. If you are interested in doing text analysis of newspapers and historical newspapers, TDM Studio is the tool that is usually the answer that will help you with that, and that's something that we are very eager to have to help you with. So if that's the kind of question that might be interesting, come to us about that. All the full text of those 25,000 articles were fed into Miguel Romero's Roberta-based financial news sentiment analysis model, from which we extracted a sentiment value for each article between -1, which is negative sentiment, 0 is neutral, and 1 is positive. This took about 6 days to get 25,000 articles. We thought it would be faster, alas. And so the idea is that 25,000 articles over 5 years will give a good sense of the financial news regarding Lululemon, and we'll know if the news is good or bad. None of the full text is in this data set. It is just the sentiment scores and an ID that we can plug into ProQuest's interface if we would want to read the actual article. The fourth data set is just 1 million yellow cab rides in New York City from 2024, January through August. Just 1 million rides sampled, and I dropped many of the columns for reasons you will see. And they come from the Taxi and Limousine Commission, like the taxi data always does. And turtles is just a list I defined at the bottom of the notebook. So so like I said, I'm going to click on this paperclip again. You can see that there are 3. Oh, I forgot to add this to the list. There's also the 2024 raw weather data is this GHC. So let me just quickly copy this usage code, and I'll add this to the text. Oh. I knew it was funny that there were 4 there, and I knew I had the turtles as a 5th one. Okay, so this Parquet file is a Parquet file listing all the hourly weather reports from USW 0009478 or KNYC 0 or the weather station in Central Park. Okay, that's all I'll put there for now. I'll add links and stuff later if I remember. Okay, so the reason I have these kinds of all these different kinds of data sets is to show a couple different things that we'll be doing today. So observable notebooks have built-in analysis tools, and this is part of the already kind of surprising aspect of this stuff, because they push this kind of no-code. They're trying to create a platform that makes it easy for people who have sophisticated ideas but aren't necessarily sophisticated programmers to be able to do some of this basic data analysis. This is the sort of stuff that you might use Excel for under normal circumstances, and the default in a research setting would be to use something like Pandas, but that has a learning curve of you have to learn Python, etc. And they create this sort of thing called the data table cell. So I thought I had this broken up. So let me show you how the data table cell works. So I'm going to try with which one of the data sets do you want to start with? The complete weather and taxi, just the weather, the Lululemon, the 1 million yellow cabs, or the turtles? The Lululemon one? Okay, so what you do is you click on the little plus sign here in Observable to create a new cell. And you choose which kind of cell you want. So JavaScript Markdown. But if you scroll down to Data Table and click on that, it just creates a cell here. And it prompts you for the name. So let's call it Lululemon. And then if you click Select a Data Source, it automatically lists the files that were uploaded, as well as turtles and the arrow table. The arrow table won't work, don't worry about it. But turtles is not a file. It's just an array I created at the bottom of this notebook. So we have the file attachment. So we pick Lululemon, and then we wait a second, and then we have this. And this just floors me, because we automatically have a little descriptions of the distributions. And we can see I can explain what all of these columns do. The index is just a number that goes from 0 to 1, to 25,000. It's how I keep track of the articles that we've processed, so we don't process any articles more than once. The GeoID is just the internal ProQuest ID that they use for the article. The date is the date of publication. So you can see it's not uniformly distributed, but it shouldn't be uniformly distributed, because it would probably be a mistake to assume that the news articles are uniformly distributed. What you can see is that 33% are in 2022. I don't know if Lululemon was especially in the news at that time, but through sampling, that's how it worked out. Tokens is a kind of naive count of how many words long the article is. So this is all stuff that I did in the pre-processing, but you can see that most of the articles are less than 2,000 words. So 2,000 words is probably, I don't know, maybe like 4 pages. And then there are some that are really long. And this is already processed. I already cut off from earlier the 20% longest articles. So this is the 80% shortest articles. And there are still articles that are like 10 and 11. These are 20-page articles. This corpus one we can skip. And then additionally, because eventually we'll be aggregating this information into day by day as opposed to article by article, we have just a list of the daily article count for every day. So if I were to sort these by date, you would see them doubled up if there were articles from the same, well, with 25,000, there have to be articles that are from the same days. Daily token sum is how long all those articles are put together. And then here we have the 3 last columns for the sentiment analysis. So again, so you can see here, text sentiment goes between -1 and 1, and with 0 meaning neutral. And is there, does anything about the shape of this histogram suggest anything to any of you? So in the middle is neutral, 1 is positive, -1 is negative.
It's skewed towards the positive sentiment.
Yes, exactly. Why do you think that is? Let me rephrase this. I don't know why this is. I only have suspicions. But why would you think that is?
I would imagine that most articles exist in the first place to sort of promote the brand.
Right.
So it would make sense for them to talk positively about them.
Yeah, that's the best thing I can come up with, is that we maybe assume that the business press is really negative and suspicious, but at least according to this model, the majority of the news is positive. And what's more is we can see that there's a pretty wide distribution between, or that a lot of the articles are sort of in between neutral and positive, whereas there are nearly no articles that are a little bit negative. It's either negative or neutral to positive, basically. The error is paradoxically, it's the inverse squared error. So the higher this value, the more confident the model is in the decision it made. But this is hard to read, but you kind of want to see it having this this type of curve, because it suggests that the error is, it's doing its job basically. And then the last one is just how long the article is according to the model, which is using different ways of chopping up words than just spaces. So, I mean, to me, this is astonishing just because we have these little charts here, but then we can do filters right away too. And if I pick a column like the date, it knows it's a date because this was saved as a Parquet file. So it was saved with the type date in that column. So I can do very sophisticated date sorting, just like this. This is difficult in Pandas. And then I can show or hide columns as I like, sort as I like, and slice as I like based on which chunks of the data set I want, etc. I had also, so that's the Lululemon one. So we have, the biggest thing here is this text sentiment. I mean, that's why we went through all of this, is to get a better sense of this, because our initial sample was just 500 articles and we saw the same pattern. So we wanted to we're just going to keep building on this thing until we run out of articles or the project is due, whichever comes first. I will I'll load another data set, which is the raw data set. So, and for this one, I'm going to quickly jump over to Google Colab and do the same thing here. And I'm going to do, the raw data set is weather DF. And I'm just going to do weather DF head to see the top 5 rows for the weather data set here. And then I will do the same exact thing here. So all I'm doing is I'm just changing this. Oh, okay, it already changed it. So what differences do you notice that you think might be useful to point out between this and this? Any differences jump out?
Well, it shows a distribution of certain
Exactly.
columns. I mean, it gives you figure of a summary of what's in that column.
Right.
So, and it says that, yeah, it has the same, so that the whole column is the same.
Yeah, so these are some things that are very helpful. I mean, we would imagine, I already told you that these are all weather data collected from one station in Central Park. So it makes sense that the station name is the same all the way through, but it also tells you that right here. And so these are all the same because this is all just information about the station, well, except for the date, which are all unique, which is also good. Then we have the temperature, which, you know, we get this sense here, but also even tells us how many there are that don't have a valid number for the temperature reading. There are two values that don't, which is strange because we got a different, well, I'll have to look at that later. And then as you keep going, even with the categorical variables, it shows the different kinds of categories that they have available and the distributions of those categories. But the most exciting thing about this for me is if in a Jupyter notebook, if you start scrolling, okay, temperature, 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 then it goes from temperature report type to precipitation 24-hour quality code. So I have temperature report type, that's this one. Oops. Temperature report type, and then the next one it shows is precipitation 24-hour quality code. But that's not the next one here. The next one here is this one, temperature station ID. So what happened? And the answer is here in the ellipsis. The pandas will only show you, I think, 25 columns wide when you ask for that result. This data set is 250 columns wide. And so I think it's around 200. It actually says down here. 234. It's 234 columns wide. Pandas will never show you all of those columns. You can ask it to print out the columns. It will print the first 10 or 15 and then the last 10 or 15. Is the only way I've figured out to be able to see all the column names within Pandas is to literally iterate over the columns and print them line by line. I can't get them all at once. Whereas here, I can just keep scrolling away, and it shows me all 230 whatever columns for the weather. And this to me just, I thought this weather data was wrong, was bad, because I was just like, it's just precipitation, and not even hourly precipitation, it's 24-hour precipitation. What do I need 24? I want hourly changes. And temperature, like that's, how is it only recording that much weather? But it was just a function of Pandas just cutting stuff out. So that's my little dig on Pandas. And yeah, and you see all these different things, and you can see all the invalid results are all orange here. And then there is one more fun thing. So if we look at the first challenge, so we have two challenges here. To graph the fair, let me just change this to, I thought I did it, but then things changed. All I'm doing is cutting this stuff out and putting it in a new cell. So that I can put code in between. Let's cut this out and put it in a new cell. Okay. So the first challenge is to graph the fare against the tip in the taxi data. So we have to use the sampled 1 million files. So I go to data table, and I select a data source, and I load the yellow cab trips. Okay. In the meantime, I'll delete this. delete the Lululemon. Okay. And then the yellow cab data is loading. And here we have the yellow cab data. So this is helpful in its own way because this is called sampled 1,000,02024 yellow cab trips, but look at the date distribution. What does the date distribution suggest? There are values not from 2024. There are values from 2002 for some reason. And the same for the drop-off. So as a result, you don't get a distribution over the course of 2024. You get a 20-year-long distribution. And then we have other things here, the passenger count, the trip distance, pickup zone, fare, et cetera, et cetera. And then we have the fare and the tip amount. Now, there are some fun things we can do here. So one is use this little orange button here, or orange little thing here with a plus and an ellipsis. And if we click on that and scroll down, we can do create chart. And then we do, for X, we pick fare amount. For Y, we pick tip amount. And then for the mark, we change it to dot. And it's a little bit pokey for me. I'm not entirely sure why. But we've got a chart, just like that. And as you can see, the origin is here. So there are negative fares, which doesn't make a lot of sense. And there are negative tips, which doesn't make a lot of sense. So we can scroll up a little bit and we can filter. So we can filter for only, I don't know, is it being slow for you if you're following along, or are you mostly just watching?
Yeah, the problem in my case is that I cannot charge the data set in the chart, and I don't know why it doesn't appear.
It doesn't appear? I tried all this earlier, so it may be because a bunch of us have it open at once or something. I'm not entirely sure with what. No. Go, like it's valuable to know what the limitations are here, and how much it might be the limitation of the fact that I'm using a 9-year-old computer now to do this also. So I reloaded, and now it'll take a second. You were going to say something, Jeremiah?
It's not showing up in here, in this. Yeah,
No,
that was my issue with it.
Yeah, so I forked. I'm working on my own observables.
Ah, okay.
But it's fine. Yeah, I follow.
Okay.
I forked it as well, and only 2 of the data sets came over.
Of the files?
Yeah, of the files. So,
Okay.
yeah.
Yeah, they might catch up. I think it might be a little bit related to all of these things. So, okay. So now everything is looking better. Why does this have the correct? Why does this only have 2024 now and look right? I didn't put any filters in yet. That's weird. Okay, but we can pick filters, so it'll take a second here to think about the columns. Actually, let me hide some of the columns. That may speed it up. It may also be because it's a million rows. It was working super fast on that machine, but that machine is 10 times faster than this one, so this was my silly mistake. Okay. Keep trying. Go, go, go. I mean, I don't know if you can even hear the fan is whirring as it's trying to do this. Okay, so let's get rid of a bunch of these columns. Okay. and then let's filter. Okay, we want the fair amount to be greater than 0. And we want the tip amount to be greater than 0. And that will suffice for the filters. And now we can try to save it and see if it'll save correctly. So in the meantime, I can explain what's going on here. So this is what this chart cell does is it launches a internal version of the plot library that we'll be talking about in a little bit more detail a little bit later, and gives this sort of stuff to you to play with as you like. Okay, yeah, so everything is crashing out. So what I'm going to do, I'm just going to quit stuff and just restart the machine. This machine hasn't been restarted in forever, so hopefully that will help. The fan stopped whirring. So it loads that little window with the little X, Y, and all that sort of stuff. And that takes the plot, the library is called plot, and embeds it into the notebook. And we'll be using plot by hand in a little bit. But plot is sort of a JavaScript version of ggplot or of matplotlib. And it helps you with, it has a lot of, it's extremely powerful and can get extremely confusing very quickly. And I just know the basics. A lot of what I know how to do in, how's the recording going?
Oh, good. I just switched back, so let's focus on you.
Oh, okay. A lot of what's going on in plot, or a lot of how I use plot is exactly how I use ggplot and matplotlib, which is I ask the internet how to do something. I can't, well, actually ggplot I can sort of remember this, but map, forget it. I always have to ask the internet and copy paste. So plot works kind of the same way, but the ideas are the same. And like I said, we'll get into more detail with that in a little bit. And the drop downs let you do the little set your X and set your Y, but then they also let you do things like facet, and they let you set the colors for using categorical data and things like that. So let's hope this works and makes things run more smoothly. The filtering and column reduction is extremely helpful, especially on big data sets like we have here. And actually, the second challenge relies on that, as we'll see in a second, assuming everything loads back up. Go, go, go. It's often easy to forget that one of the downsides of having all these kinds of things be in the browser, like Jupyter Notebook and these sorts of things, is that if your browser is not very strong and your computer is not very strong, you can suffer. Okay. Okay. All right. So we are back to here. So it actually saved the filtering, even though I didn't do anything, because now we see the origin is now in the corner. And we can see that the plot is changing as it's reading in the rest of the data. The data is probably loaded rather lazily, so the plot changes over time. And again, having the million having this be 1,000,000 marks is kind of, I'm asking for trouble. But are there any kinds of, anything jump out at you about what the shape of this data on the chart? As it slowly fills in.
Well, it seems to be more or less correlated, like positively, right? Correlated. There seems to be
Yeah, so
about line
yeah, so weirdly, so I mean this is, so you have most of the action is down here, which just means most of the cab rides are less than $50 and most of the tips are less than 20. But you can see bands at $30, $50, so these are people that are giving flat tips. If you zoom in, the bands go all the way down, like people tend to tip or often tip in solid or in whole amounts or 50-cent increments. And if you, but then there are also lines with a clear slope that represent different percentages. I'm going to stop this. I'm going to stop this chart just in case it's part of what's causing all the problems. Because now the fan is whirring again and I can't see what's happening anymore. Okay. So that means we may have to skip the second challenge because it also uses it. But I can show how, well, let me see. Oh, I don't have it on this machine. Let's give it a try. So I reduced the number of columns to just these 4. And then if I try to, then I can click here and I can do download CSV. And with just these 4, columns, the data set in CSV, so in Parquet format, you can see that with all the columns, it's 28 megabytes. In CSV, with just 4 columns, it's over 30 megabytes. But 30 megabytes is big enough to upload to, is rather small enough to upload to Observable. So I'm going to upload this data again, but as a CSV. And then I'm going to delete this cell, just in case it's part of what's causing the problem. And then I click plus here, and I make a new data table. Select as the data source the data.csv. And so this is just these 4 columns. And what I wanted to show, the reason I wanted to do this, this only works with, let me rephrase this. This does not work with Parquet files. But it does work with CSV files and may work with other ones. But it does not work with Parquet files, which is you have this little plus here. And if I click on this plus, it lets me define a new column on the fly. So I can do tip percentage, and then that'll be the row tip amount divided by row fare amount. And then I do done, and then it thinks for a little bit. And we have the tip percentages, just like that. So not, a remarkably easy way to do this. I don't know how to do more fancy types of things like refer to previous rows or something if you want like changes over time or anything like that. I don't know that that's possible. Again, this is meant for really just immediate, does your data make sense? Because like, for example, in the file that we'll be working on in the second part, which is the one I'm using for one of my classes, the taxi data and weather data, I limited it to taxi rides that were 2 hours, between 1 minute and 2 hours long, because we're just looking at Manhattan taxi rides, and the idea is there's no such thing as a taxi ride in Manhattan that's over 2 hours long. But then when I looked at the distances traveled, one of the taxi rides was 2 hours, but the distance traveled was 600 miles, which is kind of impossible. So, and I only noticed that when I imported it into here and saw the distribution of trip distances, and I'm like, that can't be right. So, you know, you can see these kinds of things and feel these kinds of outliers. The taxi data is astonishingly messy. The weather data is a little bit better, but there's weirdness in it too. So anyway, so I will create a chart just quickly because the challenge said so. The X was the date time. So I pick up date time, and then the Y, so we can see that the pickup date time again goes all the way back to 2002. So I don't like that. So let's filter the date time. Pickup date time is after 01/01 2024 at 12 o'clock. Oh, now it's letting me do 00. Oh, okay.
The year as
Ah.
an extra two.
Thank you. All right, there we go. Okay, so then it does the filter, and then this will take a second, and it will redraw this. Ta-da! So here we have the pickup date time. I actually don't know what it's using as the, frequency. So I changed this to tip percentage. And I mean, this isn't going to be anything particularly groundbreaking in terms of the, but we can see that the tip percentage is mostly under 50%, but then you have, you know, someone tipped 650% on their tip. No, I take that back. This isn't 650%. This is 65,000%. So, you know, people in New York are crazy. You know, who knows? So we can add another filter where the tip percentage is less than 1 to get an actual sense of how people are for real tipping. Get rid of some of these outliers. Okay, that'll take a little bit of time. This person tipped 1,000%. No, 10,000%. And you know, you just don't know. Does this mean that that these people are like big spenders, or does it mean that they're or just bad data? We have no real way of knowing. The Uber and Lyft data, the 75th percentile tip is still $0. So we just dropped the data. We're like, it is inconceivable that 75% of Uber riders do not tip. It's just in Manhattan, it's just impossible. So there's something about the way the data is collected and reported that we were just like, we can't trust any of this. So okay, so here's from 0% to 100%, and we see, you know, not a lot because the data is so much, but we do see fixed bands also at certain points and whatever. But this is just to show that you can create columns on the fly, you can make these kinds of changes, you can use filtering, etc., and you can see the results in your chart immediately. Hopefully it's running more quickly for you. This was very snappy on my 3-year-old computer as opposed to this one, which is from the Obama era. So these are all the basic sorts of things you can only do. You can't do very complex transformations. For that, you have to use a library more like Pandas, and the library like Pandas in JavaScript is Arquero. So there's the circuitous path that I described in previous weeks, about, thanks, about loading Parquet files into Arquero, and we get this data set, AQDF, which looks like this. So it doesn't look quite as pretty because it's not trying to look as pretty, it's trying to be helpful. So, and now I can talk about the plot. So AQDF is just the Arquero data frame. So this is the, it's this file. Oh wait, I can click here. It's this complete weather and taxi data file is loaded into Arquero. And here we have it. So plot. Plot works like this. You do capital P plot, dot plot, and what it does is it creates a detached chunk of HTML that has to be attached to an already existing chunk of HTML in the DOM. In an observable notebook, that doesn't matter because it's done automatically behind the scenes. But if you were to use plot in a regular website that doesn't have all of Observable's secret infrastructure, you have to do a little bit of extra work to attach it. It's not a bunch, but it's a little bit. And what goes inside plot is a method, so it takes, I think, just the one argument, which is a bunch of options. And the options can be things like margins, a title, then the X and Y axis, they have their own options, like saying %true. If you do %true, it'll turn decimal numbers. It'll multiply them by 100 and then add a % sign. It's very cute. And most of the action happens in the marks array. The marks array is like the geoms in ggplot. So the marks are different methods that are also plot methods that help you create the charts. And there are, I don't know, something like 50 different marks available. You can do very, very wild things with them. And I'm not going to go into them, but the most obvious ones are things like area, which plots area under a curve, or colors in the area under a curve. The axis are just options for your axes. Bar Y is used for creating bar charts. Dot makes dots. So up here, like you saw here, mark, the ones that they suggest immediately are bar, dot, line, area, and rule. So these are what dot marks look like. By default, it makes these little black circles. And of course, all of this stuff is changeable. And usually, you can also have a sort of shorthand where you just collapse everything into one call of plot. But to me, that's harder to learn. I like having the big container because then I know where to move stuff around. And plot has other features, of course, like faceting and interactivity, just like we would expect. And that's about that. Like I can't go into a lot of the details, and instead I'll just show how it works. So the challenge here is to graph average trips per hour for each hour of the day. So it's just one siren because I have the answer here. So the answer is I create a new data frame called AQDF by hour, and I use group by, which is one of the Arquero methods, on a data frame to group by hour, which is one of the columns in the data frame. So I'll show the data frame again. We have date time, which is the whole thing. Date, which is just the year, month, and day. Hour, which is the hour of the day. And then trip count. I think that's what I did, trip count. Average trips per hour for each hour of the day. Roll up is like summarize in dplyr, or like ag, I guess, in pandas, to create a new column called trips. And it's the mean of all of the trip counts per hour. So I'll go through that again. I'm creating a new data frame called AQDF by hour. So what I do is I take AQDF and I group it by hour. So everything that is 23 in the hour column gets into one little chunk. And then in roll up, I calculate the average for just the hour for 23 and for 22. So I get the average for each of those hours per day. And I end up with this plot. So I'll also uncomment this because I already gave the answer. And you see what it looks like. Is this surprising? I mean, there's no right answers, wrong answers. Are you surprised by this?
No, not really. In the afternoon, there's more. Right?
Yeah, I mean, that's what it's saying, is that the peak taxi time is at around 6 p.m. I'm a little bit surprised by it because I only take the taxi like at 9 in the morning if for some reason I'm really late to work and really have to hurry and I can't risk waiting for a bus. Or it's like in the middle of the night and I'm just so tired and I don't want to walk home. So I am. This does not match my lived experience, but I imagine for a regular Manhattanite, this does match their lived experience. They take a lot of taxis during business hours, but then it peaks around the end of the day. Like maybe you have to get somewhere to go to dinner, or you're in a rush to get to the train station or something. And then it slowly falls off, and then at 4 o'clock in the morning, no one is taking taxis in Manhattan. One of the neat, so this is how I did this here. So I think I can do things like change the label here. And it changes it here to hour number. I added a margin left of 50 so that we would see all 5 numbers for the numbers of trips. If I don't include this line, whoops. If I comment that line out, we see it gets cut off and it looks like 8,000 is doubled up. I can make silly numbers for the margin as you like, and you get instant reactivity. So 50 is fine. The other thing, and then for the mark, what it does is you can see that there's plot, and then plot bar y. So bar chart, y up and down. Just like in ggplot, the first argument is the data set. Then the second argument is the options, which is a little bit like the aesthetics. And you have a y, you have an x, and the strings correspond to columns. So that's unlike, but that's fine. And then plot rule y0, all that does is that draws the line at the bottom. So I don't, I won't know off the top of my head how to change the colors. I mean, whatever, let's try. Blue. I guess that worked. Let's try fill. Oh, opacity, it does autofill. So fill opacity, let's do 0.2. Yep, and we get this ghosty look. And you can just do all these kinds of things that you would expect to do. The one thing I really liked about this, that I gave it a try, is I can copy this and go down here and replace this like this, and it still works. So the reason I like this is because I hate assigning variables to something I will only use once. Doing this kind of quick bending and transformation of the data, like just to make a chart, just makes more sense to me as something to do. And that's it. Now, challenge 1. Easy sirens. Graph average temperature per hour for each hour of the day. How do we go about doing this? So I can probably just copy the code I already have and paste it in. Anna, you were saying something?
No. Like the
Well, you tell me.
Yeah.
Okay, so here we're trip count.
Yeah.
Okay, so yes, this will give us it'll make the right chart, but there will be funny things like it'll say hour number here. So yeah, we can fix that sort of, well, hour number, sorry, is correct, but it's here that it says trips. So instead of trips, we can rename this column to temperature, and we can call this temperature, and then we can create a Y and label average temperature degrees Celsius. And now it says average temperature degrees Celsius here. How does this look? This definitely matches my lived experience. I'm always most uncomfortably warm at around 5 p.m. I should spend more time outside at 9 a.m. Much nicer. But there we go. So that was an easy one siren. Now this one's tricky. I think I know how to do this, but this one I didn't try to do ahead of time. So graph max and min temperature per day over the data expanse. Okay. So I will copy this and paste it back in here. All right. So what's our x going to be? For graph max and min temperature per day over the data expanse.
Day? No.
Yeah,
A week or
so technically it's yes. So all right, so let's do this in a little bit more. So let's create a new data frame just so we're working on something that isn't the chart. AQDF temp. So it's AQDF, and so how do we have to change this to get per day? We have to group by date, and then we roll up, and in the roll up we create new columns. How many? I said two. We need two new columns. What are the two new columns we need?
the minimum and the maximum.
Yeah, exactly. So min temp is going to be something, and then max temp is going to be something. And then that's it, just the roll up, right? Yes. All right, what's the min temp going to be? How did we get the mean? We did an arrow function like this. You were going to say?
No, the same, but like instead of min, max, or sorry, min.
Yes, instead of mean, have min. And then instead of min here, we get max. I think this will work. I like it. Is it complaining about anything? Nope. Let's have a peek at what this looks like. So we do AQ df temp view. There's a slightly tidier way of doing this. How does this look? I mean, we know this is January 1st. So a minimum of 6 and a maximum of 14 sounds right. The next day, 1 and 6 sounds right. Are all these numbers smaller than these? Looks like. All right, so we're in business. So the data looks right. So we can delete this. And then we have to do the chart. So we have day is the label along the x-axis. And what's the label on the y-axis? Just regular temperature, because we're not doing averages anymore. Now, what do we do for the marks? Do we still do bar y? What did I say here? Graph max and min temperature per day. So how do you imagine this chart looking?
But I mean, per day, like all the days in the data?
Yeah, of which there are, I don't know,
So not a bar?
over 1,000.
Like a bit of, how it's called, a plot chart? No.
We can use lines.
Yeah, the lines.
Yeah,
probably,
lines.
2 lines, yeah.
So instead of bar y, let's try line y. Okay, now what's the df temp? Oops. Okay, what's the y value going to be of the line?
Temperature? No?
Well,
The y?
we only have 3 columns in our data set.
Oh.
Let's start with max temp.
Yeah, I mean, you need both in the y.
Yeah, we'll need both. So let's start with max temp. And then this will be date. And we won't do fill and fill opacity because we won't have any fill. And let's just try this and see if this works. Go, go, go. Come on. This was so exciting. All right, in the meantime, we know that like you said, there's going to be 2 lines. So the second one is going to be a second plot line y, and here we'll do min temp and date. And this should work, but now everything is being problematic again. So, you know, we'll see if we get, if we're lucky and we get to use this. But that'll be it. That's it. That's the hardest challenge I thought up. I've been making the challenges a little bit too hard this semester, so I wanted something where I had a good sense of how it would work. I actually thought that I would have to use date time to extract the day out of the date time, but because I forgot that we had a separate column for date that actually is saved as a date. It's not just a string of 2024-01 or whatever. It's actually a date, so I knew that it would read it appropriately and that would work. So now we are here, and let's see if this actually loads. And if not, I will make it the screenshot of the video on YouTube. So how does it look? What do you think? Pretty exciting, pretty easy, I think.
Yeah, I really imagine using this, for example, for group projects where like
Right.
one person is code like it's. So in the beginning of the group projects that we are all understanding the data, but there's no way that we can all see the same stuff going on. Of course with Google Colab, but I mean, I think this is like the demo you just did. I really imagine this with a group of projects. So I really like. If you are on your own, I still like it because I think it's very fast. Like I really like the summaries of each column. Like creating columns. So, but even more when it's a collaborative thing. I think it's pretty powerful.
Yeah, and these notebooks, we haven't even started on the collaborative, like on the collaborative nature of the notebooks, but they have a lot of collaborative tools. Like you can see here, you can add comments and do these sorts of things. Okay, it's probably not going to work. I'm not going to restart my computer again. But alas, what we would have seen is 2 lines that were both black, because I wouldn't have gone. I think stroke is how we would have changed. We could set a stroke option for both and do like stroke equals red, stroke equals blue. I don't know how we would have gotten a legend that says max temp and min temp. That would have been for next time. Yeah, I think the problem is, the hiccup is that you can't have files larger than 50 megabytes. I don't know if this is a limitation to the free version of Observable. I don't know that there's a way to run Observable like on your computer in the way that you can. I just haven't looked into it. So that may be a limitation, because in Google Colab, I'm literally loading gigabyte-sized data sets with no problems. Or that's what I'm expecting to use. So that's a bit of a, that sort of stops me. But at the same time, one of the things that I've learned working on these projects is how to greatly reduce the size of the data by doing things like getting rid of columns, aggregating, saving as Parquet. I have the suspicion now that makes a little bit of sense if you think about it, but I have the suspicion that Parquet compresses numeric data much better than it compresses string data. So trying to save everything as numeric might greatly reduce the size of your data sets, and doing these kinds of things. Not to target the 50 megabyte maximum for a size file in Observable, but to get around things like having to use Git LFS if you're trying to upload this data to GitHub. If you're using TDM Studio, you have a 30 megabyte per week limit on downloads out. So you're really incentivized to they'll bump it, like Procrest will bump it, but the default is 30 megabytes a week. So you're very incentivized not to create gigantic data sets, and just do things like that. Yeah, this isn't going to work. So I will stop with that, and that's that. Thanks for coming. Next week, or in 2 weeks,